Let's begin with reviewing some properties of fractions. What makes a fraction an improper fraction? When the numerator is larger than the denominator. When a fraction is improper, it means that there is a non-zero whole number part which is contained in the fraction. For example, when you have 13/5, that's really 2 3/5. You have a whole number part of 2 plus a little bit extra that's less than 1, the 3/5. So how do we go about finding the whole number part when we want to write an improper fraction as a mixed number? Part of the answer is given by the division algorithm. For any positive integers a and b, there exist unique integers q and r with 0 less than or equal to r strictly less than b, such that a is equal to q times b plus r. For example, when we have 13 and 5, 5 goes into 13 2 times, that's our q, with a remainder of 3. That would be our r. So how do we go about finding the whole number part when we want to write an improper fraction as a mixed number? The answer to the rest of the question is given by the distributive property. Maybe a slightly unfamiliar form of it, but still the distributive property. For any real numbers a and b and c with a not equal to 0, if we divide b plus c by a, then it's equal to b divided by a plus c divided by a. The question for you, the side question, why do we need a not equal to 0? Let's write 13/5 as a mixed number. 13 divided by 5 is equal to the 13 we can write as 2 times 5 plus 3. That's by the division algorithm. Then, using the distributive property, we divide both terms by 5. So we have 2 times 5 divided by 5 plus 3 divided by 5. Now we are naturally inclined to cancel the 5's, which we do, which leaves us with a whole number part of 2 plus 3/5. The 2 plus 3/5 is really what we mean by the mixed number 2 3/5. So one interesting thing about polynomials is that they have a division algorithm as well. Let's recall that we measure the size of a polynomial by its degree, the degree being the highest power on any of the variables. So for example, show that there are polynomials q and r with the degree of r equal to 0 such that 2x squared plus 3x minus 1 is equal to x plus 2 times q plus r. Let's take q to be 2x minus 1 and r to be 1, so that if we multiply out 2x minus 1 times x plus 2, then add 1, we get 2x squared minus x plus 4x minus 2 plus 1. So these four terms being what we get when we multiply out 2x minus 1 times x plus 2. Combining like terms, the minus x plus 4x gives us 2x squared plus 3x minus 1, exactly as we needed. The question really then becomes, how do we find the integers, or how do we find the polynomials q and r such that a is equal to q times b plus r? An algorithm with which you are probably familiar is the answer, long division. Just to remember a little bit about long division, if we divide 13 by 5, 5 goes into 13 2 times. So we place the 10 down here. 5 times 2 being 10, 13 minus 10 gives us a remainder of 3. We know that we're finished with the long division because 3 is less than 5. We actually have a similar algorithm for dividing polynomials. Suppose we want to divide 3x squared plus 10x plus 6 divided by x plus 2. Our polynomial long division looks a lot the same as regular long division and actually leads to the same kind of division algorithm. 3x squared plus 10x plus 6. X plus 2 goes into 3x squared plus 10x plus 6, a total of 3x plus 4 times, and then our remainder, negative 2. Again, using distribution, once we have our Q and our R, we can apply the distribution property. 3x squared plus 10x plus 6 we write as 3x plus 4 times x plus 2 minus 2. Using the distribution property, we divide the first two and the last term by x plus 2. We cancel terms, x plus 2 in the first product. And then finally, that's going to leave us with something that looks like a whole polynomial part, 3x plus 4 minus 2 over x plus 2, something which looks like a proper fraction. Proper fraction because the numerator is degree 0, denominator is degree 1. The denominator is bigger than the numerator. Suppose now we want to divide 8x squared plus 6x minus 12 divided by 2x plus 3. The idea is that we cancel leading terms. So we ask our question, what can we multiply 2x by in order to get the leading term of 8x squared plus 6x minus 12, namely 8x squared. So what can we multiply 2x by in order to get 8x squared? The answer is 4x. Now we multiply the 4x by both terms, 4x times 2x to give us the 8x squared, the 4x times 3 to give us 12x. Then we subtract our polynomial. This actually gives us, once we subtract, our 8x squareds cancel out. So we get 6x minus 12x to give us a negative 6x. The negative 12 comes down just like regular long division. But we aren't finished yet because the degree of what we have, negative 6x minus 12, is 1. The degree of 2x plus 3 is also 1. So what we have is not smaller than the thing we're dividing by, so we have to continue one more step. So the question then becomes, what can we multiply 2x by in order to get negative 6x? So what can we multiply 2x by in order to get negative 6x? The answer is negative 3. So we multiply both sides by negative 3. So we do negative 3 times 2x to give us 6x. We do negative 3 times 3 to give us negative 9. But notice what we have here. The signs are changed just as the signs changed up here. The reason for that is that we are subtracting what we are multiplying. We're subtracting the 4x times 2x plus 3. We're subtracting negative 3 times 2x plus 3. So all of the signs are opposite what they would be under normal multiplication. So 6x plus 6x gives us 0. Those cancel out. Negative 12 plus 9 gives us negative 3. Now we notice that the remainder is smaller than what we're dividing by. The degree of the remainder is 0 because it's a constant. The degree of 2x plus 3 is 1. The remainder is smaller, so we're done. So that what we have now is 8x squared plus 6x minus 12 equal to 4x minus 3 times 2x plus 3 minus 3. We use the distributive property to divide both terms by 2x plus 3. We cancel common terms, and we're left with a whole polynomial part, 4x minus 3, minus something that looks like a fraction, 3 divided by 2x plus 3, a true fraction because the numerator is smaller than the denominator. In the following exercise, pause the movie before you work each step. So you'll work out this division exactly as the example in the previous slide, but pause as you go through each step to see that you're doing things exactly the same. When we're dividing by a monomial, remember a monomial means you only have one term. We can get by using a shortcut with only the distributive property. So for example, if we are dividing negative 4x to the fifth plus 6 times x plus 8 by 2x squared, we can divide each term by 2x squared. So that we have negative 4x to the fifth divided by 2x squared, 6x divided by 2x squared, plus 8 divided by 2x squared. Canceling x's, numerator and denominator, and simplifying the digits, we have negative 2x cubed plus 3 over x plus 4 over x squared.